Question 2, you are given this diagram, and obviously here total resistance in the circuit, total current, voltage drop, value of the current out there, the power consumed by the resistor, list 4 factors that affect the resistance of a conductor, 4 marks. So total though is 20 marks. The key thing here I wanted to put across was this: how do you go about when given this? It mustn't scare you. Follow the current. Your current is what you need to follow. The good part about this one is they have already given you the flow of current. We are going to just label it. Now, very important, this is your total voltage. It's 24 volts. So let's call this our IT, total current here. So total current is going through R1. It is going to come out of R1. This is still IT. You agree with me? But something interesting is happening here. Hello once again, our most valued student. My name is Confident and welcome to our surprise subject and topic. This is industrial electronics, and I'm looking at the calculations of resistance, currents, voltage and power. Now the disclaimer here is I'm not an expert in this subject called industrial electronics, but one student requested that I do one topic under industrial electronics, and I was like, why not? So this is one of the students' comment. As I said, it was from Tandega, and then Tandega was like, I think he was going through electricity under engineering science, and he saw my circuits and stuff like that, the way I approached, and this was a comment to say here, I love the way you explain. Can you please do the electric circuit of industrial electronics? They are more complicated. N2, please. So that's the reason towards this channel. So if you are seeing this for the first time, I've already dealt with these comments, the importance of these comments, to say just leave your comment, drop your comment. You never know. But beside me answering your comments and everything, what is important? Engagement. You know, sometimes a student also can respond to you, and that's still an answer that you can get. But here I felt like I do electric circuits. They are not really very complicated, but you just need to know a few techniques. So that's why I'm doing this lesson, but I had to put it under industrial electronics because you don't see such questions in engineering science. So I will in a way agree with Tandega to say indeed they are a bit of work, because you find that one question is 10 marks. So indeed they need a little bit of work, but you need not panic. So let's look at the next part. Now remember guys, okay, if this is your first time coming in contact with a 24-minute lesson, subscribe right now. Don't just watch and be passive. I need you to be active on this channel. Subscribe, ensure the notification bell is turned on, and leave your comments. It gives me an idea to say indeed there are people behind this channel, you know, who are watching, who are benefiting, and you know, as a motivation in a way. Look at this one. So this was the exam written on the 17th of August 2021, and there was question 2, and question 2 was also on electric circuits. So look at this. Question 2, you are given this diagram, and obviously here total resistance in the circuit, total current, voltage drop, value of the current out there, the power consumed by the resistor, list 4 factors that affect the resistance of a conductor, 4 marks. So total though is 20 marks. The key thing here I wanted to put across was this: how do you go about when given this? It mustn't scare you. Follow the current. Your current is what you need to follow. The good part about this one is they have already given you the flow of current. We are going to just label it. Now, very important, this is your total voltage. It's 24 volts. So let's call this our IT, total current here. So total current is going through R1. It is going to come out of R1. This is still IT. You agree with me? But something interesting is happening here. Something interesting is happening there. They gave you errors there, but you know what? They were in a way a bit naughty there. They were supposed even to give you an arrow or an error there, because the current cannot just go through the resistor 5 and resistor 3. That's why, let me see the question. A voltage drop, okay, they never said current through resistor 4, but there is a current, so don't be deceived. So we have got current there. We have got current. Let's call this one I5 since it starts in 5. Then this one we'll call it current 4, and this one we'll call it current 3. So this is current 3, current 4, current 5. I hope it's fine with you. And then look at this. What goes in there? It's gonna be current what? 5. What goes in this resistor is going to be current 5. I told you, when same current is passing through, these resistors are in series. Why? Because I5 is going through R5 and R6. The same current is going through these. So we say they are in what? They are in series. And you know what to do when they're in series? You need, I'm now doing this a bit quicker, to say R series, this is our first series, is R1 plus R2, because I know it's not difficult, this one. So this one you simply say 3 plus 12, and then what is the total? This becomes 15 ohms. I'm just showing you. So they will give you a mark though, very important, you need to show that working. So R3 plus R6, it's in series, you give it 12. Now you follow again. The fact that I5, I4, I3 are in separated means these are in parallel. But don't forget, you have already found the total here. You have found the total of this one. Now that you have found the total of this one, you come up with a new diagram. As I say, it is very important to come with diagrams, but I'm going to do that with you. Now look at this, but understand this. I3, I4, and I5 are in parallel. So how will your diagram look like? It will look like this. You will have your normal flow of current from positive, I don't have to put much there. This is what you're having. And then from here, you had your resistor. The first one was this R. I mustn't make it too long. The first one was this one. It's the original one, so I'm not going to change. You got this one first. And then after that, look now how I'm going to redraw this so that you can see that they just wanted to confuse you. I3, I'm going to draw it as is here. This is I3. Don't let that diagonal thing confuse you there. They're just trying to be tricky there, but there's nothing confusing there. All right, look at this. After that one, let me not just leave those lines. What do you have? I've added these to give me the 15. Remember, I've added R3, 3 ohm and 12 ohm to give me 15. Now, because they all fall under I5, they are in parallel. So I'm going to do this intentionally. So they're in parallel here. Are you with me? So what do I have? Let me now write down. We say this one gives me 15 ohms, right? And then what about the other one? The other one is 10 ohms. This is R3, is 10 ohms. This is 10 ohms. This is my R3. Now, you might be asking then, do I put the other one, the diagonal one? You see how it is, the diagonal, the 15. How do I put it? Am I going to put it like what they did, like this, and do that? I'm not going to do that. I'm not going to do that. But look what I'm going to do. As I'm telling you, it's the same. It's the same. It's in parallel. Just come and bring it like this, just to simplify things for you, so that you can have a better picture now. This is what it seems. Whether they put it diagonal or what. But this, let me see. Be careful. Wait. I mustn't make things wrong there. This goes. No. No, you're right. This is not right. This is not right. This is not right. This is not right. I think I'm forced to put it. Let me see. I think it's correct. Because, okay, this went there. this went there and this went there, but at the junction there. So yeah, it's still the same. Even if it's coming from here, it was still gonna be the same. It's in parallel, it's in parallel. It's still, that's correct, guys. Let me put back my diagram. It's correct. It's correct. Trust me, it's correct. This is the answer. Why? Because it's in parallel. Even if I was using my formulas, I will say I3, I4, and I5. They're in parallel. I'm gonna use 1 over R1 plus 1 over R2. So the formula is gonna still give me the same. And this is how the diagram, I might maybe I have not put it right, but the diagram still is like this, because the answer will be the same answer. So the other one there is what? 3 ohms. This is 3 ohms. Yes, this is fine. This is a plus, this is a minus. Look at the flow of current, what I'm trying to bring to attention here. The flow of current is, this is your IT, and then we called it this I3, right? And then said current coming here will be what? I4. See that? And then we said it is what? It is 15 ohms. But the one that I have already kind of added, I'm going to use a different color, is this one. Remember, it was not the original. We did something here. Are you seeing that? So now that's where I got my I4, my I5 here. Remember, after adding, then I apply the formula to say 1 over R parallel 1 is equal to 1 over R1, which is R3, plus 1 over R4 for I4, plus 1 over R5 for I5. I'm using the same thing as the current that I was using. Then I need to add, I think this diagram I made an error. I forgot this part. Well, I'm going to put it here. It's not a transmesh. You just have to put it there. Okay, so don't panic. It's still there. It's still there, guys. It's still there, guys. But this is correct, okay? Don't think that I'm doing this wrong. It's correct. But you can leave me your comments, guys. Look at this. And then it's a matter of adding there, which is 1 over RP, R parallel 1, is equal to 1 over 10 plus 1 over 15 plus 1 over 15. Okay, so now I told you how to do R parallel 1. Therefore, you can say therefore it's 1 over, which is 1 over 10 plus 1 over 15 plus 1 over 15. You do that, then it will give you the final answer. Alright, then RP1, R parallel 1, the calculator just comes in handy there. So it is going to be, in this case, 1 over 1 over 10 plus 1 over 15 plus 1 over 15. What does it give? 30 over 7 SD 4,285. But let me leave it now like this, 30 over 7. But what is 30 over 7? It's 4,285. 30 over 7, which is equal to 4,285 ohms. I'm interested in 30 over 7, the original number. Okay, so we've got this, guys. Here, the total of this. Guess what? We continue. I'm going to draw. Okay, let me just show you how I can simplify this diagram for me to make things easier for me. It won't even complicate. So I'm gonna take this whole diagram, duplicate it, take it away here, so that you can see how easier this becomes. So in this diagram, I'm going to now erase all of this. I've got the one resistor now that has been added together, and I'm gonna erase all of this, and that resistor is now 1. It has become okay, let me just erase everything like this. I've got one resistor now, which I can account for this. Okay, I can account for here and here. It's now one resistor that I've added. I'll make it bigger to say it's a combination, you know. So that particular resistor is the one that we added here to say it gave me 4,285, the total resistance of this. So here I got 4,285 ohms. So you see, now all of a sudden, look at the current. The current goes there. It entered as IT, coming out is IT, going in is IT, coming out is IT, back it's IT, coming out is IT. See, it's just current, that same current, meaning they're in series. So the answer is there now. R series, or RT now. I don't have to worry now, say R series is equal to R1, I'll call it R3 plus R parallel, that P1 there, plus R4. I'm saying P1 because it was that thing there. I don't want to write that 4,2 blah blah blah. So now what am I adding? RT is equal to, then I'm adding the 3 ohm plus the 4,285, or the 30/7 plus the 4. You can actually use 30/7 there if you want to maintain the actual decimals properly. So you can say 3 plus, it was actually 30/7, just for the sake of rounding off, plus 4. Then press SD. There it is. It's too long. 79/7, which is 11,286. 11,286, 3 decimal places. 11,286. I don't know what they say is the number of decimals. Usually it's 3 decimal places, 2 or 3. So there is our R total. That's the answer they wanted here. Find what? Total resistance in the circuit. 6 marks. That's it. Move there, move here. I'm now moving a bit faster because you know what, we've been doing this. Now the total current in the circuit, 2 marks. You go to the final circuit. This final circuit gives you the answer. So what was that? This question was 2.1.2 total current. 2.1.2. So if they want the total current now in here, you say, remember the part I said, you need to know the formula. What does it say? V is equal to IR. Remember, V is equal to I times R. And then we agreed that to use this formula, I'm just gonna take this thing up because I don't want it to waste my space here. And then I said you need to know the triangle here, like this. You need to know this. You definitely need to know that this is V, this is I, this is R. Now they want current. Now current is equal to V over R. Similar question they are asking. Now total current, that's T. IT is equal to, now you ask yourself, they told us what is the voltage. I didn't put there, but there is the voltage, 24 volts. So it's fair for me to come here putting 24 volts so that I don't lose that number. 24 volts, you see how it's like. So it's fair for me like that. So which means voltage is what? 24 over total resistance. That's your IT, 11,286 over 11,286. Or you can use that fraction that we did. I mean the fraction, it was 79/7, something like that. And then you get the answer here to say 24 over 11,286. Alright, there you go. Then what we get? 2,1265, which is 2,127. 2,127. 2,127. Current is in amps. Don't forget. That was the answer. Next question. the voltage drop across resistor R3. So let's look at R3. There we go. They want the voltage drop across resistor R3. Now, what are they trying to say? They are saying if I'm to connect a voltmeter here, what will be the answer? Now, let me give you this. Remember, they are parallel. The answer you get even here is the same. But now I can't put these first because they are in series, but I can use this diagram. Now, this is the perfect diagram whereby you can say the voltage that I get here, if I put a voltmeter here, the voltage across here, I put a voltmeter. The voltage is the same for that, and that. If I put one here, voltmeter, I get a reading, and I put another one here, a voltmeter and R3, and I put another one here, a voltmeter, I'll get the same answer. All these will give me the same answer. Why? Voltage across parallel resistors is the same. So what does it mean? It means I go to my next diagram and ask myself, what was the total of these three? Remember, they gave me this one. The total gave me that, 4,285. So, which means when I look at this question, which is 2.1.3, I can therefore say in question 2, what did it weigh? Here, it's much better here. 2.1.3, because I just did 2.1.4. You use the same formula. Now they want what? They want, the question is looking for voltage drop. So the formula, remember, V is equal to what? V is equal to IR. So that's what you use straight. V is equal to I dot R. Now, you ask yourself, what current was passing through, because we're using this, it was IT, which is the current we just got here, 2,127. So it's 2,127 times the resistance is the resistance of the parallel one. It was RP1. We got this RP1, where we're adding to get 10, 15, 15, it gave us 4,28. This is the one that we're doing here, 4,285. You see? So here times 4,285. Then it gives me the voltage only in those ones. So it will be 2,127 times 4,285, 9,114. What? Volts is voltage. That is V3, because it's across the resistor 3. The value of the current passing through R3. Now they want current that is passing through that 10 ohm. Remember, R3 though is 10. So now we have to say, okay, we know that in here the voltage is what? The voltage is we just got the voltage, so we can find the current only. It's the same formula. I is V over R. What is that question? This was 2,13. I can come here and say like this, and make it 2,14. Use the formula I, but in current 3 in I3 is V over R. The voltage, we just got it down here. That passed through that 9,144. Because it's V3 over. Now the resistance of R3 is this one, is 10, you see? So it was not really complicated, that one. It's 10. So I3 is equal to, I think it's 0,9144. That one is not complicated. It's 9,144 over 10. 10 is not a difficult number to divide. 0,9144. Because we are looking at 3 decimal places, is 0,914. So guys, I think you're seeing what we're dealing with here. And then, what is the other one? The power consumed by the resistor R2. I like that one because we haven't done power. Power consumed by the resistor R2. Let's look at this one. Where is R2? R2 is 4 ohms. So if you look at it, there is the 4 ohms here. But the good part about the 4 ohms is what? Let's go to the other diagram. Look at the current that is going through. The 4 ohm is getting IT. So which means we are back to our total current, which is what? Current that went through was 2,127. And then after that one, we know the resistance is 4. Then that's why I said you can use these formulas. I think I don't have now the formula, but there is a formula here that connects resistance and power. Remember? Let me show you this. There is a formula which says P is equal to I squared R. There are different formula. P is equal to V dot I, or P is equal to, what is the other one? V over R squared, I think, like that. You can use that, but here, this is the interested one. I don't want that. I don't want that for now. VI, simpler one is this one, whereby I know the current was what? IT was 2,127 times the resistance is also known is 4. So it makes it things similar. So it's 4 squared. And then when I do that, it simply gives me the power. Say 2,127 times 4 squared. It's what? It's 34,032. So it's 34,032. Power is in watts. Don't forget. It is in watts. Don't forget. Okay. Then what's the last question of this one? That was 10 marks. Now let's say list 4 factors that can affect the resistance of a conductor. Now resistance of a conductor, number 1, we can say the type of material can affect it. Number 2, we can say the temperature can affect it. Number 3, what is it again? Is the diameter or the thickness of the wire, or diameter. How thick your wire is, it will affect. Number temperature is type of material, temperature, thickness, and resistivity of the material, resistivity. But I think this can end up being linked to that. Resistivity of material as type of material. And what's the other one? Say thickness or area of the material. Remember, I think it's linked to that thickness. I'm trying to think of the 4th one. What list 4 figures? I think the resistance of a conductor is the resistivity of the material, the thickness, the length of material. It's just that I don't have my formulas, but there is a formula, is what is PL over A, resistivity. I think there is that formula there, where the area, which is the diameter, is involved here, the thickness, the resistivity, the length, and the temperature. Remember, so these are the factors that will affect. Now guys, we have come to the end of our lesson again. As I said, I'm going to do this lesson just to show you a sneak peek. April 2021, there was this question here. I'm just gonna do it in the next lesson. 18 marks. If I were you, I will also tune into the next lesson, but before I do that, I will make sure I subscribe. Guys, I'm clenching my teeth and I'm saying you need to subscribe right now. If I was near you, I was gonna pull you by your ears and say, go and press that button now. Put a finger on your head and press it a little bit so that you can feel the pain to say, why are you watching without subscribing? I'm joking, guys. That was just a joke. But anyway, thank you guys for tuning in, and it's always a pleasure for me to bring you these videos. It is industrial electronics. It's a surprise, but only on this topic. Please don't suggest more topics. It's just for one thing that came across, because resistors are just an identical topic that are offered in engineering science. Thank you.